Hi, welcome back to Mr. Slover's Math, and today we're going to talk about area of parallelograms. So our warm-up is asking us to circle to identify all of the true statements that are always true of a parallelogram. So in a parallelogram, you have opposite sides that are parallel. That is true. In the word parallelogram, you have the word parallel. Here's the word parallel. Your opposite sides of a parallelogram are congruent. That is true. Your opposite angles are congruent. That is true. Your same side angles add up to 180, or maybe you heard it as consecutive angles equal 180. That is also true. All four sides are congruent. That is not true. They just have to have two pairs of opposite sides congruent. Likewise with letter D, you do not need all of your angles to be congruent, nor do you need all of your angles to be right angles. So for purposes of this class, just A, B, E, and F are always true. There is another property of a parallelogram, but we don't need it to find the area of what we're doing today. So is a rectangle a parallelogram? Is a square a parallelogram? And the answer is yes, because it meets the statements of a parallelogram. It has opposite sides that are congruent, has opposite angles that are congruent. This is 90, this is 90, same thing here. This is 90, this is 90. Opposite sides are congruent. It has opposite angles are congruent. Same side angles equal 180. You may be thinking, well, how is this a parallelogram? It's a square. Well, a square has all of those properties of a parallelogram and a rectangle. You may or may not remember that, but that's okay. It does. So think about automobiles. There's a lot of different automobiles out there. Maybe you have a Chevy, maybe you have a Ford Taurus, maybe you have a Honda Elantra. Okay? They're all different types of cars, but they are all automobiles. The automobile is the big umbrella. The parallelogram is the big umbrella. The rectangle is a specific type. The square is a specific type of parallelogram. So that's why it meets those requirements, or that's why it is a parallelogram. So example 1 is just asking you to figure out which one's a parallelogram, which would be considered a parallelogram. So A and C, it meets the criteria. Okay, yes, letter A is a square, but it is also considered a parallelogram because it meets those properties. And you may be thinking, well, why does it matter if we have a square or a rectangle or a parallelogram? Well, because we're finding a parallelogram. For purposes of this class, we're not doing a separate lesson on area of a rectangle or a separate lesson on area of a square. We don't need to get into that for purposes of this class. We're going to say that a rectangle, a square, and a parallelogram, we're going to use the same formula, which is base times height. So if you heard a rectangle before to find the area is length times width, that's fine. It's similar to base times height. For a square, you have side squared. Well, you could also say it's base times height. Okay, so all three of these, we're going to use base times height, where B is our base. Once again, it's not always on the bottom of the figure. H is the height. And once again, that is by the right angle. So we've got 6 examples here. It says find the area of each parallelogram. So I have a base, I have a height, multiply them together, and I label with units squared. And in this case, it's feet squared. Square feet is how you would say it. So over here, square feet, over here, square feet, over here, square centimeters. Now this is a square. Okay, we know that because I have one right angle and 4 sides congruent. I bring that up because I only have one side marked. But just like I circled, this means that these are equal or congruent. So if this is 1.6, this down here is also 1.6, or over here, or over here. It doesn't matter. To find the area, though, we still do base times height. So 1.6 times 1.6. Over here, we have base times height, 38.5 times 14. This symbol here that I circled, the 1 apostrophe, means feet. And so if you're ever looking at a scale model, you're looking at a model or the layout of maybe an apartment you're going to rent or a house that you might purchase or rent, and they have that symbol, that just means feet. And then letter D, I have extra information in here. Sometimes you get extra information. You do not need the 23 or the 23. Okay, here's my base, my height's by my right angle. Multiply those two together. E and F are not drawn, but they are still able to figure them out. Base times height, it's a parallelogram. Multiply them together. It's a square with a side of 12.2. So think about what we did in letter B. We had 12.2, and then the other side was 12.2. Multiplied them together. Example 3, we are working backwards. I give you the area, and you need to find the missing measurement. So here's our formula. Area equals base times height. I'm plugging in the information I know. The area, 130 square feet. Remember, I'm not putting in 130 squared. I'm not putting in 130 feet squared. I'm using the value, the 130. That's going to equal base times height, 20 times x, or x times 20. It does not matter. You get the same answer. So 130 equals x times 20. I divide by 20, and I get 6.5 feet. Notice my label on all of these have no power because they're all a length. I'm finding the length of this side. I'm finding the height of this. Finding the length of this. I'm finding the height of this. There's no squares, no square units in our labels here. And then number 5 is asking you to draw an example of a parallelogram. So just like we've previously seen, here's my area, and I'm going to work backwards to find my height or my base. You pick a number that is less than the area. So 10 is less than my area. So it would be 105 equals 10 times x, divide by 10, and I get my height is 10.5 meters. So once again, my answers vary because it depends on what number you started with. As long as that number is positive and is less than your area, it will work. So today we found area of a parallelogram, which is base times height. And for purposes of this class, we are lumping the rectangle and square